Meiosis, the Business of Genetic Diversity, presented by Tom Seaborn. Meiosis I separates homologous chromosomes. During interphase, organelles and chromosomes double. The cell prepares for division. Prophase I. In prophase I, chromosomes condense from chromatin. Homologs connect during synapsis and crossing over occurs, a process where alleles are exchanged between two homologs. The points where crossing over occurs are called chiasmata. While this is occurring, the nuclear envelope is dissolving, and the centrosomes, microtubule organizing centers built around two centrioles, move to the poles of the cell, and spindle fibers in aster form. Later in prophase I, the microtubules attach at the kinetochores and start movement to the metaphase plate. This process is different from mitosis because of crossing over and the bonding of homologs, not just sister chromatids. Next, after prophase I, is metaphase I. Notice there is no prometaphase like in mitosis. Chromosome pairs are arranged at the metaphase plate by the pulling of microtubules. Both chromatids of each homologous chromosome are attached to kinetochore microtubules from opposite poles. Anaphase I. Following metaphase I is anaphase I. During anaphase I, homologs separate and move towards the opposite poles, guided by a spindle fiber's reeling action. Notice the chromatids from the homologs remain attached to the centromere. Telophase I cytokinesis. By the end of meiosis I, each half of the cell has accumulated a haploid genome, which is already duplicated. In some cells, the chromosomes decondense and a nucleus forms. A cleavage furrow forms in animal cells and two haploid cells are formed. Next comes meiosis II, which repeats the same basic stages but is much simpler because it does not involve crossing over. Prophase II is not preceded by interphase but continues directly from meiosis I. Spindle apparatus forms and chromosomes begin movement to metaphase II plate. Metaphase II. In metaphase II, the chromosomes are partitioned at the metaphase plate by spindles. Different from mitosis, the sister chromatids are not identical due to crossing over. Next is anaphase II, where the chromosomes are separated when the centromeres break down, and the chromatids separate and move to poles. Notice there's one chromosome from each parent on either side. Telophase II and cytokinesis. During telophase II, nuclei form and chromosomes decondense. Also, nuclear envelope forms and nucleoli take shape. Now, 4 haploid cells have been produced, each with a distinctive genome. This process has produced gametes, which are essential for sexual reproduction, and create a great amount of diversity. Meiosis creates genetic diversity in 3 main ways: independent assortment chromosomes, crossing over, and random fertilization. Meiosis and mitosis are different in many ways. For example, meiosis involves 2 divisions, mitosis involves 1 division. Meiosis involves synapsis, mitosis does not involve synapsis. Meiosis creates 4 new haploid cells, mitosis creates 2 new diploid cells. Meiosis focuses on gamete production and genetic diversity, while mitosis focuses on growth, renewal, and asexual reproduction. I hope you enjoyed this film. Thank you for watching. Tom Seaborn signing off.